The first ellipse is the Earth traversing around the Sun, and it's called the ecliptic. The second ellipse that you see there is the Moon traveling around the Earth in red and in blue. These are very small compared to the brown ecliptic. Like a fast rotating top losing speed, the Earth's axis is precessing around this axis. The Earth's axis will never point in this direction, but it rotates like a cone around it. The Earth takes 25,800 years to do this precession, and there are 2 points where the axis is near vertical in the sense of the ecliptic. It's not quite the same, but they're the nearest it can get to the vertical. And there is a point where the Earth has dipped towards the Sun, marked in red, and these 2 points above where it's near vertical are marked in dark blue. And the Moon's orbits change considerably, and they are shown as the red ellipse and the dark blue ellipse around the Earth with the Moon in it. Remember that the Earth revolves around the Sun once every year, so when Earth is pointing in the direction of the red hot axis, we've got the poles getting a lot of light, and because of that the poles melt, ice melts, and the equators are not very hot. They are temperate, and there's a lot of water in it, and the ice bleeds all of its water into the oceans, and the oceans start getting up. This is the Great Flood when it happens. Now when the Earth tilts away and points near vertical in between these 2 blue axes, the poles don't get much light. They get light at an angle from the Sun, so they get colder. When they get colder like that, they make ice, and the equatorial region is bleeding water into steam, and that gets into the poles and becomes ice. And this explains the Ice Age, like 11,000 years ago, where we had ice all the way up to Manhattan. Here's where we are with tilt at 38 degrees. You see the Moon flying in front of SDO, and you see the angle it makes as it traverses across the face of the Sun. You've got to lend me a bit of grace here. I'm going to explain this. The first picture shows the Earth tilting to maximum towards the Sun. You notice the small axis with respect to the ecliptic's perpendicular, and as seen from the Sun, the smaller the axis, the more tilted it is towards it. So the pole is tilted towards the Sun, and we are naturally losing ice at the North Pole, and it's probably summer, and the peak of summer is being felt at like 45th parallel, like Seattle, Maine, etc. And this is pretty much a good tilt, and this is probably the tilt that will happen, and all the ice will melt, and during winter Antarctica will lose its ice, and we'll have a lot more water than we can behold. Now in the second picture, you've got Earth tilting nearly perpendicular to the ecliptic, and you've got a lot of ice in the North Pole because there's not much light that's coming through there, and the Sun pretty much burns the equator. You've got a lot of sunlight coming there and not much coming to the poles. Though the Sun looks pretty big in these pictures, if you look at the Sun outside, the Sun is only 2.5 to 3 degrees in terms of how much it inscribes, which means the sunlight is coming from that kind of an angle, that kind of straight angle to us. And at the poles, if it is tangential, which is what it'll be, there's not much heat that it can put on the Earth. The ice obviously doesn't melt in a single year, but every year the North Pole gets a chance, then the South Pole gets the chance during winter, and they get exposed to a lot of sunlight, and slowly they both bleed their ice away into water, and the oceans start filling up. So what's shown here is a cylinder of the precession axis. This can't be moved. The axis of the cylinder cannot be moved because that's a constant for Earth. Now, if you look at the current rotation of Earth, let's assume it's at max tilt, near max tilt. This is the red axis on the picture on the left. You notice that the moon is at a really sharp angle, and you've got the plane that goes through this axis and the cylinder, right? Now, if you draw a perpendicular line from that plane, that's when, if the sun is at that position, then the Earth gets even light. So this is the place where the northern hemisphere and southern hemisphere get the same amount of day and night. So this is the equinox. Now the line that's perpendicular to that, that's the Ocker line. That line facing the sun would be the solstice line, where you'd have the northern hemisphere slanted most towards the sun. This is the usual per year cycle that we go through. Every 6 months we move from summer to winter, and this is what explains that. Now you go to the second picture. This is the picture where you've got the Earth at a least tilt with respect to the ecliptic, and that's marked by the blue axis. And now the moon's plane is sort of parallel to the ecliptic, sort of. It's never parallel. And now you notice that the solstice is at a different angle than before with respect to the cylinder, and that's the same thing with the equinox. So which means the equinox, as you tilt the axis of the Earth, as it precesses, the equinox also sort of changes in degrees. So if you look at constellations in space, the equinox was pointing somewhere else, and now it's pointing somewhere else. What does the equinox pointing mean? Equinox meaning behind the sun, the constellation starts differing, right? And the solstice markings currently are March 22nd. Meaning the equinox markings are March 22nd and September 22nd, and the solstice is June 22nd and December 22nd. The astrology, the astrological folks split this up, these 6 months up into equal 6 months and 6 months, and that's why you've got this weird August 22nd. After August 22nd, you're really in Virgo and not in Leo, sort of thing. The evidence for the previous slide can also be seen here. In the Hindu astrology chart, the year's beginning is the equinox, or the April 15th. Currently we know that equinox happens on the 22nd of March, and In the Rig Veda, we have seen that Kritika, or the star Kritika, meaning the end of Aries and beginning of Taurus, was mentioned as the equinox, which means the equinox precesses because of the precession of the earth. So if the poles have shifted, then the equinox should fall on a different day. Not only do we see changes in the moon's orbit, we should also see changes because we're thinking about the constellations. With reference to constellations, if precession's taking place, then we know for a fact that the pole star would not be the North Pole, the axis. You would shift off it, and here we show in the slide that you would have the pole star doing circles and the Ursa Minor doing circles which are bigger than what it's doing right now every night. So if you have a 8-hour time-lapse video in that direction, we'd see the circles becoming bigger. The pole shift does not happen with respect to the constellations, the universe, the rest of the universe, if this circle does not become bigger. So what we need is a proof that these circles have gotten bigger. The Ursa Minor, now when it puts out its contents, like it says in the Rig Veda, should cast different circles. The stars should cast different circles.